Hi everyone, I'm Toto. I'm going to introduce the history about the chemical cell that applied in vehicle. Let's begin with the first electric car in the world. The first electric car was the car you can see in the photo, and it is a four-wheeled open carriage with only 1 horsepower electron motor, a rechargeable lead-acid battery, and a top speed of 9 mph. You might think the year is a typo, but it actually that 18,000s were actually chock full of EV related innovations. But the early 1900s, numerous electric cars were on sale and being used for local range and in cities, as much as they are today. But modern electric cars were just popular again in several years ago because the early 1900s cheap gasoline super EV performance and the lack of environmental concern ultimately spelled doom for this initial crop of electric cars. But the fact remains that modern EVs stand on the shoulders of pioneers from more than a century ago. Okay, so let's take a look of the reaction of lead-acid battery. First, the anode side reaction is Pb react with H2SOs actually, or you can write it as HSO4 negative. So next is the positive, the cathode side, as it is lead dioxide react with also H2SO4, and this side accept electron, and these two sides, the total reaction can be written as the Pb that lead and the lead dioxide that react with H2SO4, and in this reaction it can generate about 4.05 voltage as a standard cell potential. Although the standard cell potential is low for a single cell, as we can see, much normal electronic products are like computer is about at least such over 10 volt, but we can use series connection to gain higher voltage, so it doesn't matter actually. And let's take a look of the principal diagram of this lead-acid battery. It's just like that, and you may see that the positive and negative electrode are put in a same solution, but it actually doesn't matter because we can separate them and use a salt bridge to connect them, like Na2SO4. That's we can actually separate them, divide them, yeah. And then we take a look about the advantage and the drawback of lead-acid battery. The advantage is cheap because it's a mature technology to produce lead-acid battery nowadays, and it is a high surge current because so we can see a lot of lead-acid battery in some like small electronic motor, and because it's a good feature to power small vehicle like motor. That's so we can accelerate in a short time, and it's good for the vehicle's performance. And then it's a mature technology because after the lead-acid is being created over 100 years ago, so it makes like this kind of battery is cheap and safe, but it also has some drawback, like it's low energy density. Low energy density is caused by the large molar mass of Pb, about 207.22 gram per mole, which means to produce 1 mole electron, we need to use at least 103.61 gram Pb, not mention other material like H2SO4 and other materials. And this kind of lead acid battery has another drawback is short cycle lifespan. You can see that it can only use about 300 to 500 times totally only, such as the battery from 100% to 0%, and we charge it from 0% to 100%. That we repeat this process for about 300 times to 500 times. This battery will break down, and it almost can't be used anymore, or like it can't have such good performance as when it's a new one. And this also has a long charging times because the lead acid can bear low charging current. That's why the charging time is very long, and it also have environmental concerns because the waste lead acid has a lot of Pb2+. This ion is a kind of heavy metal ion, and it's very harmful for our environment. So this is a drawback, and that's why the lead acid is generally going out from our vision. Next, it is a brief introduction of lithium-ion battery, which is the most popular battery all over the world. Nowadays, you can see this kind of battery anywhere of our life, like my pet, or even some cars, and anywhere, like even drones and flying to like space, everywhere that you can see it. The lithium-ion battery is the most widely used chemical battery now. We can find it in vehicles such as Tesla and some other hybrid cars. You can also find them in some small electronic devices such as phones, drones, and cameras. It can be produced various of size and shape to just different requirements. Thus, you can find this kind of battery in almost all the electronic products. Then let's take a look about the reaction of lithium-ion battery. So the anode side is the process to consume. Like you can regard this as a LiS because C6 is a container of Li metal. So you can see they are this whole entitled as a Li plus C6, and C6 is actually like a box that contains a lot of Li into it, and then when you want to use the electron in the Li that's saved in Li, then then it put the Li out, and then Li and electron separate away, and then you get Li, and it is energy, just like the box. And then here is the C6, and this is Li plus and an E negative. And then here is cathode. So it's just like you have another box, it's called CO2. This is another box. You received it can receive the Li plus, this ion, into it, but you also need an electronic. With this, they go into the box together, and then you can get this, and this is the full reaction. Thus, you can regard the whole reaction as Li lithium from one box to another box, And this is the process of the whole reaction. But although it is a wide used kind of battery, but it also have some drawback, and it also have some advantage that make people to use it. The advantage is its high energy density, because the Li, you can see it is the third element in the belt, in the table, chemical table, and it only the third, so it's very lightweight. It only 6.97 mole gram per mole. It's very lightweight than the lead, than lead, and so it can contain much more electron than the lead, and it also have a long life cycle from about 2,000 to 5,000 times. It's very you can use it for a very long time, such as we charge our phone once a day, and that means if the cell that's applied in your phone is very very well, and you can use it about at least 10 years if it have still can use 10 years later. And then it also have a good advantage that features that it can fast charging. It can bear about 4.7 voltage into that you add into it, because for the lead acid battery it will maybe overheat and even explode if you add too much large voltage into it. So it only even about twice as much as we can add to a lead acid battery. But it also have some drawback, because such as it's costly. Although the manufacturing technology is becoming more and more mature, it's still more expensive than lead acid battery, because the lead is not a lead but other technology, and you need to use to produce this lithium ion battery is very hard to achieve and maybe expensive. And it also has some safety concerns that the overcharging and overheat can make the battery explode. That's why that maybe our parents will warning us that you can't play your phone while you're charging it, because it really will explode. The most famous example is the Samsung's phone that several years ago. It's very famous, and at that time almost nobody in my country buys the Samsung's phone. And another drawback of the lithium ion is recycling challenges, but it's not the challenge that we have to how to recycle and reuse it, but we have to find it, because the enormous surge of usage of lithium can result mineral resource exhausted. But the technology of recycling lithium element in waste battery is still challenging and expensive now, so we have to know how to recycle and reuse it, but not like find more resource from our earth. Yeah. And next is the future of the like chemical battery is the solid state cell. To overcome the drawback of lithium ion battery, scientists are trying to change the material of electrode and electrolyte to improve safety and efficiency of the cell. Due to the low molar mass of lithium ion, lithium is an excellent material to build up a high energy density battery. The solid state battery can be regarded as an improvement of lithium ion battery. So then I'm going to introduce the difference between solid state battery and lithium ion battery. First, for the normal lithium-ion battery, the material of electrolyte is liquid state or gas state, which make the battery unstable in extreme situations such as very low temperature or very hot temperature, and energy capacity will sharp decline in such cold temperature. For the solid state battery, the material of cathode is solid state like LLZO, LATP, LGPS, and PO, which is they are very complex compound, and the anode is some of the solid state is use metallic lithium, so that is why it's called solid state battery. And the advantage of solid state electrolyte is higher energy capacity because you just use the lithium directly, but not use a box to contain it. So you can put more such and electrolyte such then you can put more electronic into same space, same large space, so it has a larger energy capacity and more safety because it won't, such as if you stroke the battery or cut the battery, use a scissor. For the normal lithium-ion battery, maybe it will explode or such as get fired. But for the solid state battery, it won't have such chance to like get on fire or such as explode because it uses solid state electrolyte, and it can hardly react directly with positive and negative electrolyte, and a wider working temperature range because it uses a solid state electrolyte material, so it won't be frozen in cold temperature. So yeah, that's why you can see the electronic vehicle is not such normal like in China or other warmer region, and because in like the winter the driver range of such EV is very short if you without warming up the battery. This advantage makes the solid state battery be the future direction of batteries chemistry. But it also has some drawback of the solid state battery. Although solid battery is as such has such more benefits, it still has some shortcoming waiting to be overcome. For example, solid state battery has lower conductivity than normal lithium-ion battery for using solid electrode. Besides, it's still under researching technology, so the manufacturing cost is very expensive. That's why you can almost see the solid state battery that applied in our phone, because this phone is a kind of most need the energy capacity situation, because the space that can use to contain a battery in one phone, even Pro Max or such more larger like pad, is also limited. So we need to get a higher energy capacity to longer the time we use the phone. Make the time we use the phone longer and prevent. So that's why the solid state battery is not widely using. Then I'm going to introduce the reaction of solid state battery. You can see the reaction of solid state battery is not such complex as you imagine, but the electrode material is. So the principle is same as lithium-ion battery, that just you put Li from one box to another box, and in this process, principal energy goes down, and you release principal that's the energy stored in lid go away, and then by a form of electrode, and then you get the energy in the box, and then the lid without any energy, that electrode was stored in another box. And whatever lithium ion battery or solid state battery, their overall principle is that Li release and accept electrode to generate energy. Okay, that's all. Thanks for watching.